Okay, so let's get started with chapter one, transformer models. So, in the introduction section, where we are going to learn how to use and implement and fine tune large language models, the most important part would be introduction, and we have to master this. And on this, we are going to build subsequent knowledge, right? So, okay, for this slide, let me move my camera towards bottom. So, chapter one, transformer models, that's what we are going to go into. And even inside that, it is divided into these 6, 7 subsections. And let's go into the first one, which is Introduction to Natural Language Processing. Okay. So, what's the agenda for it? The agenda is this. First, we'll try to understand what is NLP. Okay, its definition. Thing is, these definitions are not important because we need to answer these in a exam and get marks. Okay, no, that's not why definitions are there. They're there so that we can understand what the subject means, what it does not mean. So, definition, you can write your own. As long as it encapsulates the subject completely, it is the right definition. So, it is for our understanding purpose, and we need to, that's why do this. And then, why is this challenging? Why the skill of doing LLMs and natural language processing? Why is this a valuable skill? Why not learn something else? Why this is a disproportionately rewarding skill if you master. So all of these things we will see here. How Hugging Face course solves these NLP problems, that will also will come cover in this video. And how would future progress of NLP post 2024 will look like. Okay. So first, natural language processing. If you think of it as three words, in that, let's focus on the first part, which is the language part. Okay. So, language, what is language? So, thing is, since we are born to even now, every single second we have been processing what we see since we opened our eyes, and we have been processing what we hear. So, language is such an integral part that we haven't actually defined it. Language is a way of communication. But it's not just that. Think a bit further. Animals also communicate. Dogs communicate, cats communicate, birds communicate, even fishes, dolphins communicate. So, communication, if we just define language as just communication, it doesn't do justice to it. If the language is simplistic language, the things you can communicate are limited. What dogs can communicate, what ants, small tiny ants, they communicate with each other through the chemical smell, the chemical they have in their sac on their body, they communicate through that, the trail they leave. So we can communicate, but the things you can communicate through it as are limited. So language goes, human language, natural language goes beyond that. Then what if we think of it as ways of capturing complex concepts? Now, this starts capturing the complexity of language, this way of definition. So, for example, we were, as a farming, if you take a look at history of humanity, we were farmers, but we were farmers only for 10,000 years. You should check New Era of Human Calendar video by Kuz Gazak. It's one of the most amazing videos I've heard. So it puts into perspective how long we were hunters for, and then we became farming thing. So in if when we were hunters, right now this study has been done. They studied a tribe which was so isolated from rest of the world that it has developed its language separately. So in that, they have so many words to capture weather, language, temperature, the things, how soft the ground is disturbed, and stuff like this. So we can't even detect these gradations of temperature. They have a lot of words for them because that affects weather. Weather affects animal behavior. Animal behavior will affect how they hunt for them. So they have captured something which goes beyond what we humans can see simply because of language. If instead of hunters they were, fishing communities, they would have so many words and concepts for, and they will be able to detect so many subtle differences in sea patterns, in weather patterns. So it language allows you to capture that complex intangible concept. French people, It's they have a lot of words for love and emotions and romance, and because of that, the emotional landscape of humanity is captured more vividly. So they have captured something more than other languages have. If you think of any domain expert, engineer, doctor, soldier, whatever it may be, whatever that domain, there are so many specific concepts the words in that domain can allow you to capture. So you see, language is way of capturing complex concept and so many different kinds of concepts. And it can not only capture, it goes even beyond that. The power of language goes beyond that. It is a way to store knowledge, transfer it over time. So, through books, through articulation, through words, and then listening, through teaching, you can actually not only capture these concepts, complicated, powerful knowledge concepts, but you can also transfer them, store them. Imagine knowledge of Newtonian physics, chemistry, antibiotics, engineering, machines we can build. These things, the huge buildings like pyramids, how they were built in the past, or airplanes we build now. All of that knowledge, it has been saved into textbooks, and through when we read that, we can actually also capture the same knowledge and we can apply it. So language is beyond capturing, it is about storing the knowledge. But it's not even that. Language goes even further than that. It is way of building intelligence. If you think of knowledge as collection of facts, intelligence is ability to reason and think, find answers, ask the questions about missing knowledge we have, improve the existing knowledge, grow our knowledge. So intelligence goes beyond whatever is established. Language is still a static way of capturing things. It is still in the past, but intelligence allows you to go further, expand, do what is impossible, and in so many directions you can grow. So, the language which we speak, it is very powerful even though we dismiss it. Entire history of humanity, the whatever scientific progress which has happened, it has happened because how the language stores knowledge, and when enough knowledge has been accumulated, that has led to humanity progressing. So take a look at humanity's history of 70,000 years. We were hunters and gatherers. And in that, if you take a look at how language captures knowledge and how that knowledge has what led to our humanity's civilization, that is how what language is. Imagine language of gods. Imagine language of super advanced aliens. How much knowledge they have, how much intelligence they have. Language is a means to of that intelligence, and that's why it is amazing. So what is natural language processing? Natural language processing is everything related to human languages. It goes beyond just collection of facts. Okay, it goes so much more beyond that, but it's a starting place. So everything to do with human languages, ability to understand what is being spoken, ability to communicate your intention, whatever you have, ability to collaborate. Multiple people through communication can do a complex thing together and not just write down. A subject like Newtonian physics or particle physics or even how to build nuclear fusion. Nuclear fusion is attempting to build sun on earth so that our entire energy needs are, we solve them in one shot. So it's such a complex problem that it needs to be solved over generations. And that generations, that happens multiple different people's work together. So you see, ability to understand, answer questions, translate, write, everything to do with those languages, that is what natural language processing is. So we understand the entire collection of existing knowledge. Not no single one person can. That's why we have specialists who know subset of the knowledge. So that is what is the linguistic related part of natural language processing. Then the other part would be intelligence related, going beyond knowledge as collection of facts, extending on top of it, building on top of it, maybe extracting knowledge in something which we have not extracted it before. So NLP is related to intelligence. For example, there are large language models built now which can understand how biochemical comes together to build the proteins. So maybe we can build a much better antibiotics now. Maybe we can build much better virus killers, whatever it may be. So ability to extract patterns so that we can understand them, NLP helps us build that, because it is related to intelligence. Intelligence is ability to think and understand, and as long as we are given data, we can learn from that data set. So NLP is not just language parsing, but also related to intelligence. So that is how the story is connecting from language to natural language processing. The thing is, NLP comes easy to us humans. We can easily speak and understand at least one language, just like how walking is easy for us. Walking is so easy for us that we don't even think that getting a robot to walk is a hard problem. Check Boston Dynamics' last 20, 30 years of progress. Even getting a robot to stand is a difficult job. There are so many muscle components which need to be adjusted dynamically. If you simply stand up, okay, you can only see my stomach, but if you're simply even sitting down in a this balanced way, this has so many muscles working together, so much data is being read, and brain is figuring out things to do. So it's hard problem. Just because it comes easy to us doesn't mean it's not hard. Driving, for example, still companies are trying to build self-driving cars. It's hard, but it's easy for us. We have so many drivers. Looking and identifying objects, identifying this pen for a pen is easy for us, but it's hard. It's hard. Understanding language words, it's easy for us, but it's hard. So NLP as a domain is very deceptively hard. It just feels easy, but it is actually not easy. And if we go in terms of how many languages and what they capture, so all the slides in which I built up, how amazing the NLP is. How think of the languages we have in the world. Many of them, many of the languages are being endangered because not enough people speak them. Then the knowledge which is contained in the language, the literature, the myths, the society, that's so amazing. So all of these details, all of these linguistics things, and how this language and how our brain responds to these things. There is a mapping of these things in our brain. We can actually see them visually here. So a brain scan was done while story, depending on the word, whatever part of the brain spiked is what is captured here. I think my PC hanged a bit. But this website allows you to capture whichever word triggered some recognition activity in the brain. That is what is captured here. So, language, so many languages here. If we check, then it's like number of languages. We have at least 23 languages with 50 million speakers. Then, different populations, blah, blah, blah. So, this is insane. If we check on internet, we have the most spoken language is English on internet. So, and now most of the science is written in English. That's why English and internet, we have so much more data which needs to be processed. So all of these things, okay. So all of these things correspond. All of these things correspond to natural language processing and how hard it is to do that. So, do not think NLP is easy. Right now, NLP has become easier to get started because of Hugging Face. Just because you can write a code and see it run and get some results does not mean NLP has become easier. NLP as a problem is a huge problem. It's nowhere near solved. We just right now are at a place where approximate solutions are easier to available to us. So Hugging Face makes it easy, but the problem is not easy. Okay, so it allows us to just in one line, two, three lines of code, it allows us to do a very complicated thing. So how does it look like? I'm just going to show you one line code from the next lecture, which is going to come. Mm, okay, not this one. So import pipeline and build a model and simply say whatever sentences I want to do sentiment analysis on. The sentences I've used, I love you and I hate you. So one is positive, one is negative, obvious. It is confident about positive 99.998. And it is also confident about I hate you 99.99 0.99911 something something something. So just two, three lines, it is allowed us to do that. That is what Hugging Face has done. But we need to build on top of it, make it understand nuances of the language we have chosen, make it understand nuances of the problem we have chosen. And that's where work will always be needed because intelligence is infinite. We can keep going on top of this. And that intelligence, if you have to capture, we have to go beyond just brute force, stupid, blind experimentation we have in LLMs right now. That is not being scientific at all. I hate how that happens. It is simply a programmer's way of blindly running things without doing any attempts of understanding a more fundamental complex problems. So I will share a few videos I think will open your perspective. So first video is what is intelligence and where does it begin? So in history of how animals evolved, so what is intelligence as an entire journey of that? This video talks about it. It says how a complex intelligence is in reality a combination of basic tools. On top of it, we have fancier tools. On top of that, we have creativity, planning, stuff like this. So the basic tools, it's like tools like memory, vision, ability, information, memory, and learning. These are the basic tools. So it allows us to understand how intelligence is a very complex and long process which has happened in history of evolution. Okay. So with LLMs and with NLP, we need to go do it like this. We need to quantify intelligence better and then improve our LLMs accordingly. One of the things right now is 1,000 brains intelligence. So this way of approach right now quantifies our current human intelligence to at least 1,000 different kinds of intelligences. So we don't have models which follow these things. We right now only have a very simple one. So there is a lot farther to go in NLP as a domain. Okay. Then there is this another video which is origin of consciousness. It is in the exact same thing, just like how animals evolved and how is the origin of consciousness and intelligence. This video talks about that. It will give you a perspective on intelligence and how it originated. After you have studied how it has originated, how complex it is, only then you can appreciate how complex intelligence is. So for that, you should check this video. Can you upload your mind and live forever? So it will tell you how complex it is to even uh, take a photograph of our current intelligence. Let alone replicate the intelligence, but if we just have to capture a static representation of our intelligence, even that is impossible and will be impossible for next, I think, 200-300 years even to understand our intelligence and have this thing, but we are much farther from it. So our brain is amazing, so is AI. We need to learn to work together with it, and for that we need to go beyond confines of running these deep learning models just blindly. We need to understand intelligence, we need to understand deep learning, where it comes, what are its strengths, what are its weaknesses, and then go on the problem and try to solve that problem. So future of NLP, what the NLP holds. So I talked a bit about perspective of NLP. Let me now talk about how NLP is as a domain. So one of the amazing problems and AI has solved is protein folding problem. So it allows us to detect if how the structure of a protein is going to be. Protein made up of molecules, and in 3D, that protein, if we can build, that protein can, solve problems or diseases we are having. So if you look at it, protein folding as a problem, it feels like, AI deep learning has solved it as a hard science. It understands all the rules of interaction, why this happens that way, why that happens this way. It feels like we have full understanding of that domain. Do we? No. Deep learning is an experimental science. It's not a hard science yet. We do not understand the inherent domains, inherent rules of a domain. What we have approximation of those rules. We need to refine them further. A science, soft science, becomes hard science when we understand the rules thoroughly. It is not approximate. It is not randomness based, maybe. So we understand something so deeply that we have full control over it. So journey of any science is go from soft science to hard science. Deep learning right now is more towards soft science. It is more experimental science. Even though we do it scientifically, it does not mean we understand what happens and why. It is not a hard science like Newtonian physics. So that is what is the current state of NLP. So going to this lecture, which is Hugging Faces, this part, what is NLP and why it is challenging, and some few points I added on my own. That is what is the first section of this transformer models of Hugging Face course.